When an object is spinning, it has angular momentum. Angular momentum is made up of the speed of the spin multiplied by the radius of the spinning object multiplied by the mass of the spinning object. Angular momentum remains constant while the object is spinning unless an outside force, such as friction, comes in. If nothing else changes, the speed and direction of the spin will remain constant.
By holding our legs out, we are making our radius large. By pulling our legs in, we are making our radius smaller. Since the momentum in the mass must remain constant, the speed of the turn is correlated to the radius of the object.
In this experiment, the pop tab bounces back and forth between the two cans and a finger. When the TV is turned on, static electricity builds in the foil. No circuit is complete here because there is a break between the two cans and the pop tab. When the finger is introduced, the pop tab's electrons repel from the finger's electrons.
When the tab touches one of the pop cans, the tab becomes charged with static electricity. Now it has an excess of electrons that it wants to get rid of. The tab repels away from the first can and hits the other can. The excess electrons are put into the second can. The tab then repels away from the second can's electrons and moves back to the first can where the process repeats.
In the egg and bottle experiment, the burning piece of paper heats the molecules of air in the bottle and causes the molecules to move farther away from each other. Some of the heated molecules escape out past the egg that is resting on the mouth of the bottle. When the flame goes out, the molecules of air in the bottle cool down and move closer together.
Since there are some molecules left in the bottle, there is less air in the same amount of space at the same temperature. This creates a low pressure within the bottle and a high pressure outside the bottle. Normally, the air outside the bottle would come rushing in to fill the bottle. However, the egg is in the way. The push or pressure of the air molecules outside the bottle is so great that it pushes the egg into the bottle.
Water is a great substance for soaking up heat. The thin balloon allows the heat to pass through very quickly and warm the water. As the water closest to the flame heats up, it begins to rise and cooler water replaces it at the bottom of the balloon.
This cooler water then soaks up more heat and the process repeats itself. The exchange of water happens so often that it keeps the balloon from ever popping. On the bottom of the balloon remains soot. The soot is actually carbon left behind by the flame.
Sound is caused by vibrations. With this experiment, lower frequency tones cause more movement in the oobleck because the mechanical resonance of the oobleck was lower. The higher pitched sounds have a higher frequency or more vibrations per second.
More vibrations don't equal more movement in the oobleck. Instead, it is the lower frequency sound that causes the oobleck to shake. Although there are fewer vibrations per second at lower pitches, these frequencies cause more motion in the speaker cones and cause the oobleck to move.